In this lecture, we will learn about stacks. A stack is another type of collection that Java supports. The best way to explain a stack is the concept of LIFO, last in, first out. Think about a stack of plates. If we put plate A, then plate B, then plate C on the stack, the plate at the top is plate C. When it comes time to grab a plate, we will grab the top plate. With a stack of plates, you would never go below a plate and grab another plate. You would take the next plate from the top. The last element added to the stack is the first element retrieved from the top of the stack. Pay special attention to this lecture on stacks and the next lecture on queues, because it is a favorite topic of interview questions for programming jobs. To begin working with the stack data structure, we will import java.util.stack at the top of the code. Inside of Java's main method, we will create a stack of strings named stack that we set equal to a new stack. To add an item to the stack, we use the push function. We will type stack.push and pass in the string a to add a to the stack. Then we will push the string value b onto the stack. Finally, we will push the string c onto the stack. The stack data structure usually supports 5 main operations: adding an element to the stack with a push method, removing an element from the stack using the pop method, clearing the stack using the clear method, checking if the stack is empty using an empty method, and checking the value of the top element on the stack using the peek method. To remove an element from the stack, we use the pop method. Note that pop also returns the value of the element we removed. For example, we can use system.out.println and pass in stack.pop. Then we will also output the value of the stack to the console to see what elements it is holding. When we run the code, notice that C was printed out. We popped it so this value was both returned and removed from the stack. Notice that when we output the stack to the console, it now only holds the elements A and B. The clear method will remove all of the elements from the stack. For example, let's call stack.clear and then print out the stack to the console. When we run the code, notice that the stack is now empty. To check if the stack is empty, we can use the empty method. For example, at the bottom of the code, let's print out stack.empty. When we run the code, notice that false was printed out since our stack has elements in it. To easily see the inverse of this, let's comment out the 3 lines of code where we push elements onto our stack. Then when we run the code, you will notice that true was printed since the stack is empty. Peek allows us to check the value of the top element on the stack, but not remove it. Whereas pop will return the element and remove it, peek will just return the element without removing it from the stack. Let's print the result of stack.peek. When we run the code, notice that C was printed to the console. In the next lecture, we will learn about queues.